All right. All right, so we're starting your very last unit. What? You'll have at least 30 minutes at the end. Maybe a little bit more depending on how we do, you know. You need to take a nap. Wow. Okay. Just a little, okay. All right, so let's jump into your very last unit. Okay, then after that, we'll have maybe like 2 weeks to review for the AP test. And then you'll be graduating. Who knew? It would come so fast. All right, so remember that when you do an integral, okay, there are 2 ways that you can do it. The first way that I taught you is fundamental theorem. Fundamental theorem is when you take the antiderivative, you plug in the endpoints, and then you subtract. So if this is my function, what's the antiderivative of that? So x goes to a squared, and then I have to divide by 2 on the half, which makes it a fourth. What's the antiderivative of 5? Okay, technically plus c, but nobody cares because we have endpoints. Then we're going to plug in the 4 and the -6, and then subtract. Let's do the 4 first. What's 4 squared? So that's a fourth of 16 plus 5 times 4. What would that be? 20. So a fourth of 16 is 4 plus 20 gives me 24. Okay, that's my top value. Now we're plugging in a -6. What's -6 squared? Okay, and I want a fourth of 36. Anybody got that? 9. And then plus we want 5 times -6, which would be a -30. What is 9 minus 30? -21. And then what do we do with those 2 values? So it'd be 24 minus -21 means plus. So 24 minus -21, it'd be 45. Okay, so that's one of the ways that you should know how to do an integral. Okay, the other way is by remembering that an integral measures how much area is trapped between the curve and the x-axis on the interval that you're talking about. So if it's a 1/2 x plus 5, I would graph it. What does 1/2 x plus 5 look like as far as like the shape? Is it like a U, a V, a line? No, it's a line, straight line. Okay, the 5 is the y-intercept. And then the 1/2 is the rise over run. So you just rise 1, run 2. Rise 1, run 2. Okay, then go the other way. And then remember, it's the area between the graph that you just shaded and the x-axis, but then only on the interval that your integral shows. So if it's a lower value of -6 to an upper value of 4, I would shade here to here, and then just stay between. Now, remember that if you're doing this with, if they're asking you to evaluate the integral, it has to be a shape you can calculate the area for. So in this case, what shape is that? Trapezoid. So it'd be 1/2 base times height. Remember that the bases have to be parallel to each other. So that means that my height is this way across the bottom. So it'd be 1/2. How tall is this base? This one is 2. This one is 7. And then my height through the middle, it'd be 6 on this side, 4 on this side, for a total of 10. 2 plus 7 is 9, times 10 is, cut it in half, 45. Okay, so notice that no matter which way you do it, you should get the same answer. Okay? So the last unit that we're going to cover on the AP test is going to be you having to find the size of various areas. Okay, but we already know that if I want area, I do an integral. So a sandwich region, this isn't like a real mathematical term, but just kind of go with it, is where you have one function on top. Let's call this f of x. And then you have another function on bottom. Say it's here. We'll call it g of x. And that the area that you want is trapped between them. So I don't want the area all the way to the x-axis. I actually only want the area between f and between f and g. So we'll say this is going to be x equals a. We'll say this is x equals b. Okay, the way that you would calculate that area, okay, for the yellow region is you're going to integrate f from a to b. And that would be all of this area to here. Now, is that what I want? No, that's too much, right? Because all that bottom part, I don't want to include. So what could I do with the area that's under G? Subtract it. So you're going to integrate f, that gives me this whole yellow. Then I'm going to minus the integral that's under G. And then whatever's left over, that will give me the pocket of this region that I actually want. Okay. So I'll put this is the area between. So I'll integrate f, integrate g, and then minus. Now, because both of your integrals have the same top and bottom endpoints, most people will integrate them together, but they'll just do the minus in the middle of it. Okay, so the top one technically is right, but if you're integrating between the same two x's, there's no point usually in separating them into totally separate antiderivatives. Okay, so here we go. Take a look at your steps at the bottom, then we're going to do an example. First thing you're going to do is sketch the region. Okay, they're not going to give you any crazy equations that you shouldn't know the general shape for unless you have a calculator. Okay, second thing you're going to do is find intersection points. Okay, you don't always have to do this, but sometimes you will. We'll go over when you need to. Okay, then you're going to set up your integral f minus g, where f has to be the top function, and g of x has to be the bottom function. Oh, wait, it actually says that right here, but you can just write it again if you want. All right, so go ahead and turn the page when you're ready. And let's sketch the equations for number 1. So it says, find the area bounded between x squared and negative 2x plus 8. So let's do a little sketch of that. What does x squared look like? U, and does it shift up, down, left, right? None of those, right? Because it doesn't have any like pluses or minuses. So your x squared will be like this. Okay, negative 2x plus 8. What shape is that going to be? Straight line. Where is it going to start at on the y-axis? And we'll just say that's 8. And then the negative 2 would be down 2 over 1, down 2 over 1, but it's a sketch. So we're just going to draw a downhill line. So we'll say, here's my line right there. Okay, if you want the area bounded between them, that would be this section right here. The reason we're calling it a sandwich is because you have one function that's the top border. The other function is the bottom border. Okay, the problem is, in order for me to know where my region stops and starts, I need to know where these intersect with each other. Okay, so label those ends of the region as x equals. Okay, but then we need to know how to find those intersections, which is something that you should have covered in Algebra 2. To find where graphs cross each other, you just set their equations. Okay, so I'm going to put here intersections, set equations equal. So in this case, I'm setting the x squared equal to the negative 2x plus 8. Now, because I have an x squared and an x, I got to get everything onto the same side and then factor. So I'm going to bring my 2x and my 8 over to the left-hand side. That means my x squared is now going to, or my 2x is now going to be a plus 2x. What will happen to my 8? Minus 8 equal to 0. And then we want to think about what numbers would times to 8 but subtract 2. Okay, it'll have to be 4 and 2. So if I have a negative 8 and a 2, I know my options are 1 times 8 or 2 times 4. If I pick the 4 and the 2, which one should I put the negative on so that the 2 stays positive at the bottom? The smaller number, which is the 2. So it'd be an x minus 2 and an x plus 4. Thank you. Okay, which means that my actual intersection points are going to be the opposite of those. So this one we're saying is a minus 4. This one will be a positive 2. All right, so now that we have our graph, we found our intersection. Step number 3 is we're going to set up our integral. So put area equals. What are the x's for our boundaries? We're starting at -4 and we're stopping at 2. And then when we subtract our functions, we need to make sure that it's top minus bottom. So which function is the top of the shaded region? Is it the curve or the line? The straight line is the top. Okay, the curve is the bottom. So I'll do -2x plus 8 minus x squared. Okay, let's take our antiderivative. I have a -2x plus 8. What's the antiderivative of the -2x part? So x will go to an x squared. Then I'll divide the 2 on the -2 in the front. It'll just be a minus. 8, what's the antiderivative? 8x. And then for my x squared, it's really a minus x squared. It'll go to a third x. Then from there, we're going to plug in our endpoints and subtract. So capital F of 2, then capital F of negative. Okay, let's do the 2 first. 2 squared, how many? So that's a -4. Plus 8 times 2 is 16. And then 2 cubed would be 8. So I want -8 thirds. Now, if you have multiple whole number pieces, I would just combine those. So if I have a -4 and a plus 16, okay, we're going to rope that in as a 12 minus 8. Okay, that's my top value. -4 next. What's -4 squared? 16. But then it's going to go down as a -16 because even though when I square it, the negative goes away, okay, I have a negative also in front of that. Okay, then -16 times 8. Or wait, sorry, -4 times 8. -32. -4 cubed is 64. What type? Negative. And then if I times it by a -1/3, it's going to be a plus 64 thirds. Then combine those whole number pieces, negative 16 and negative 32. What's that going to give me when I combine? Negative 48 and then plus 64 thirds. Okay. Then remember, it's this minus this. But because I have two whole number pieces, I can do those together. And then I have two third pieces, I can do those together. So the way that I'm going to write it is I have a 12 minus a negative 48. And then I have a minus 8 thirds minus a 64 thirds. So remember, it has to be the top minus the bottom, but you can kind of group them into like terms. Minus a negative, this is going to go plus. 12 plus 48, how many is that? 60. And then if I have a minus 8 thirds minus 64 more thirds, how many is that? 72 thirds. But now 72 can divide by 3. That's going to give me 24. So we'll have 60 minus 24, which would be how many? 36. So the total area trapped between those two curves, okay, would be 36 units. Okay. Questions on that? All right, let's try to knock some of these out quick. Go to number 2. Sketch your graph. So my equations are 4 minus x squared. How is that going to be different from this x squared? What's the minus going to do? Instead of it being like a u up, it's going to be a u down. And then the 4 in the front, that's going to bump it up. So I'm going to start at 4. We'll say that's here, and then make my u go down. G of x equals negative 12 minus x squared. That would be down here. And then because it doesn't have any like numbers with it, that's just going to be a flat line across or a horizontal. Okay, go ahead and shade your region. I want to stay between those functions, then I want this right here. Which means that step 1 is going to be to find where that region starts and stops. And I noticed that they both happen at intersection points. How do I find those intersection points? Set them equal to each other. We're not going to do number 3. So for my intersection, I'll let the 4 minus x squared equal minus 12. Now, I could get everything on the same side here and solve. But if you only have an x squared and you don't also have the x, you could just get the x squared by itself. So I'm going to do that instead. So I'm going to minus this 4 across to get rid of it. Negative 12 minus 4 more is how many? Negative 16. And then if I have a negative x squared equal to a negative 16, I could just turn both sides positive. And then take the square root. And where is this going to intersect? At x equals what? Now, but I see 2 intersections. So what do they both have to be? 4 and negative 4. Very good. So this one is going to be x equals negative 4. This one is x equals positive. All right, over here to the side, go ahead and set up your integral. Area equals. And then remember, it's going to be whatever the domain of your shaded region is, and then top minus bottom in the integral. So what are my boundaries going to be? Negative 4 to 4. And then how will I subtract line minus curve or curve minus line? It's got to be top minus bottom. Curve minus line. So my curve is the 4 minus x squared. And then minus the line would be negative 12. Now, before you do the antiderivative, if you have pieces that you can combine like terms on, you should do it. It'll just make the antiderivative process easier. So for example, if I have a 4 and a minus -12, that's really 4 plus 12, which is how many? So this is really 16 minus x squared. And then what would your antiderivative be? 1/3 x cubed. And then you would plug in the endpoints and subtract. Now, I understand that some of us are a little behind on our homework. So rather than working all of these out by hand, okay, we're going to just type it in. So remember, you have a Math 9 button that you can type it in just like this. Okay, so you should know how to do it. Okay, but just to shorten our notes up a bit, we're going to hit Math 9. We're going to go from -4 to 4. And then our equation was a 16 minus x squared. Now, for your homework, if you decide to do this on a few questions, I don't care, but you can't round. So you're going to have to be able to turn that into a fraction. Okay, you can use the math enter to switch that over into a fraction. So 256/3, okay, would be how you would have to type that into your delta math. Okay. Do we understand the idea? Okay, so then I'm just gonna put. All right, go ahead and skip to the next one. Go ahead and sketch your graphs for me. So we have a e to the 4x, that's gonna be the same shape as e to the x. And then a 5 minus x, we should be able to sketch that. Anybody need more time with this? All right, so e to the 4x, we're just gonna sketch it here. Okay, we know it goes like this. And then 5 minus x is going to be linear. Where is it going to start on the y-axis? 5. And then if it's a minus x, should it go uphill or down? So we'll do 1, 2, 3, 4, 5 is here. And then downhill. Okay, it says I want to be bounded between them. So when you shade, you want to stay between here and here. Now, you'll notice that I stopped at the y-axis. What instruction here tells me to stop at the y-axis? First quadrant means that this is a side and I have to stay on this side. Okay, so this would be my region right here. Okay. Now, we are going to need the calculator to find this intersection. Okay, technically, if this were the AP test, you should still set them equal on your paper. Okay, but they would have to give you a calculator to be able to solve this. So go ahead and type in your equations as y1 and y2, and then you should know how to find the intersections. Remember, it's second trace, and then I think it's 5. So once you hit graph, you should see the picture we sketched. Bless you. So second trace, option 5. And then enter. Then remember on guess, you want to get kind of close to where they cross. It doesn't have to be perfect. So these cross at 0.382. And then technically, I think the 4 is followed by a 6. So let's change that to a 5. All right, so set up your integral. Now, I haven't labeled it, but where are we starting the integral if we have to stay in the first quadrant? What x? 0. Very good. So my area is going to equal the integral from 0 to the point whatever number, 3825. And then which function will come first when I subtract? Will it be the E or the line? The line, because where is the line on the graph? The line is the top and the E is the bottom. So it would be 5 minus X minus E to the 4X. Okay, and then just to save us a little bit of time, we're going to just put it into the calculator. So math 9, to open your antiderivative, and then just punch the stuff in. Okay, be mindful of the fact that you want to do y2 minus y1 when you subtract them. Okay, because you typed in your E as your y1. Maybe I'll see that. Could be math 9. 0, 2, 0, 1. Remember alpha trace is to pull up your shortcut. Okay. And that would be your amount of area right there. Anybody else get that? 0.9348. Okay. When you're ready, type in your equations for the next one. Okay, I do want to point out to you that this is a 0.5. So when you type it into your calculator, make sure that's a 0.5 in your y2. Okay, then once you hit graph, I want you to think about how many regions are between the function. So there's my straight line, 1/2 x plus 1. Okay, there's your cubic coming through. How many little pockets of area get trapped? Is there just one? There's 2. You have this little piece right here, and then another piece right here. So let's draw that on your paper. Here's your 1/2 x plus 1. And then your cubic runs through twice, that it goes here, here, here. So you actually end up with 2 little subregions that you're going to have to find each of their areas on their own and then add them together. Okay? Now, after I sketch the region, what's the next step? Even though we're going to do it in the calculator, what do I do next? Starts with the I. Find the intersections. Very good. For the intersections, you're going to set f of x equal to g of x. But then because we have a calculator, we're not going to do it by hand. We're going to do it in here. So it's going to be second trace, option 5. Remember, for first curve, you're pushing enter. Second curve, enter. But then for guess, you want to get close to, I'll find the third one if y'all will find the other 2. So the third one, this is x equals 1.2071. Anybody have the first one? -1 as a whole number? Okay. And then we need one more in the middle. -0.2071. Okay, great. Okay, then if you look at, I'm calling this a combo region. Again, sandwich and combo are not real math terms. They're just for kind of as we're talking about it. Okay, the reason I'm calling this a combo is because you're going to have to do more than one integral. So you're going to break the region down into subregions. So I'm going to call this pocket A and pocket B. And then you're going to set up an integral for each piece and then just add them together at the end. So for pocket A, what are my boundaries for my integral? From where to where along the x-axis? So this is -1 till, yes, 0.2071. And then in pocket A, which way should I subtract? Should I do the line minus the curve or the curve minus the line? The curve minus the line. And remember, the way you tell that is who's on top. So if the curve's on top, that's g of x minus f of x plus. Now we're going to do pocket B. What are the endpoints for pocket B? From negative 0.2071 until 1.2071. And then when I subtract for pocket B, I need to make sure the line's on top. So it'd be F minus G. And then in your calculator, you'll just literally put that in. I wouldn't even do it in 2 steps. I'd just do the whole thing in 1 line. So you'd go to your regular home screen, Math 9, -1, 2071. Make sure you subtract them in the right order. Your G is your Y2. The second one will be Y1 minus Y2. So that's what I got. Questions on that? So it was 1.715. Okay. Now, one thing I will tell you is on the AP test, don't call this Y1 and Y2. If they're called F and G on your paper, when you're writing them down, you should also call them F and G. If you want to kind of label them like this is Y2 minus Y1, that's fine if you want to like sneak that in there, but call it what it's on for the AP test. Okay. All right, go ahead and turn the page. I think we only really need to do 2 more. And you can do that. Okay, next one I want you to do is go to number 9. Or wait, no, number 8, sorry. Okay, go ahead and just directly put the equations into the calculator. So we're doing this one right here. So graph both of these. Oh, wait, no. This one. Sorry, 7. This one. All right, so graph both of those in your calculator. We have an x squared, pretty simple there. And then a 6 minus x. Okay, now, once you have that graphed, I want you to look at the way that this one is worded. We do not want the region enclosed between these. So read the way that the region's described. It never says between. Here's what it says. I want to be bounded above by these functions. What that means is that those functions need to be the top of the region. And what does it say I want to be bounded below by? The x-axis. So rather than you staying between the 2 functions, they're going to take turns forming the top of the region. Okay, so, and if it's confusing to think about that, when it's talking about bounded above, think like Canada. Bounded below, we're bounded by Mexico. So these are both the top border. X-axis is the bottom border. The reason that this is going to need to be broken up is because is there always one function forming the top border? Or is it always the same function across the top? No, then you're going to have to split it into two pieces. So kind of pretend it's like two pockets. So we're going to cut our region right here down the middle. And then we need to know what that number is. How can we find it? Do it in the calculator and find the intersection. Okay, notice there are two intersections, but you don't want this one. You want this one. And I believe it's a whole number on this. It, 2. Now, the other two endpoints for the region are here and here. Those are not intersections. What types of points are these? X-intercepts, very good. And to find an x-intercept, you're gonna just take the equation and set it equal to 0. So I'm gonna take my x squared equation, set it equal to 0. Then I'm gonna take my 6 minus x, set it equal to 0. So set equation equal to 0. Now, these are obviously going to be pretty easy. If x squared is 0, how do I solve that? Square root, the square root of x is 0. That's this guy. And then if I let 6 minus x equal 0, I can literally just add the x across, and my x is going to equal what? 6. So now I know that my region ends at 0 on this side, 6 on this side. Okay, this is sub-region A, sub-region B. We'll do 2 integrals, and then we'll add the answers together in our calculator. So area equals, let's talk about region A. What is the domain that it starts and stops at? 0 to 2. And then for region A, what's the top border? Is it F or G? And when I say top, I mean the top border of the shaded region. What's like it's Canada? F. Now, the bottom border would be the x-axis, right? That would basically be 0. Okay, so this is top minus bottom. Okay, then for my pocket B, what x does it start at? 2, and it stops at 6. But then for that section, that subregion, who's its top border? G, and then minus the bottom is the x-axis. So we'll just put a 0. Okay, but if the bottom is the x-axis, then you can just consider that as 0. Okay, then in your calculator, type the integral in. So it'd be math 9, 0 to 2. F of x is my y1. I'm not going to bother to put the minus 0, but you can if you want. Okay, and then 2 to 6 under function y2 dx. Okay, for your homework, can you type it in like this? No, turn it into a fraction. If you're supposed to be doing it by hand, it won't let you type in a rounded answer. So 32 thirds is the correct answer for the total area. Okay. All right, last one we're going to do is number 8, but we're going to have to kind of fiddle with it because the problem doesn't really make sense as is. So for number 8, will you sketch the region? So we have a square root 2x, that's going to look like this. We have a 10 minus x, which means it's going to start at 10 and then come downhill like this. But it says both of those are going to be bounded above on the region. That means those are the Canadas. Those are the top borders. What does it say it's bounded below by? -2 would be down here. So if this is the bottom border, then I want to make sure that I shade all the way to those top functions and then pass the x-axis all the way down to where the orange line is. Now, the reason the question doesn't really make sense is it says we're in the first quadrant, but obviously if we're shading all the way down to -2, then we're not stopping in the first quadrant. So if you'll just scribble that part out, okay, so that it's not wrong. All right, find this intersection. It's probably a decimal. So go ahead and type your equations into y1 and y2, find where they cross. And remember, technically, if they only cross once, you don't really have to get close to the intersection. So I got x equals 6.417. Okay, next question. Where are we starting the region at? What x here? 0. And then where we stop the region is going to be where these two functions cross each other. So extend your graph a little bit further. Okay, there are two ways for you to find this intersection. You can introduce a y3, which is fine, or you can just set them equal by hand, which I think is going to be easier for this one. So for this intersection, remember, you just set the equations that you want to cross equal to each other. So I want this straight line, which is 10 minus x, to equal the -2 line. So I'm going to take 10 minus x, just set it equal to what I want it to cross. Minus that 10 across. What is -2 minus 10 more? -x is -12. Then where do these actually intersect? +12. So this point right here would be. Okay, split your region into 2 subregions. And then again, remember, why do I have to split this up? Does the bottom border change functions? No. What function does change though? The top border. That at the beginning of the intersection, who is my top border? Is it the line or the curve? The curve is the top, but then on the other side, it switches to where the line is the top. So go ahead and try to set up your area function here, and then we'll check it. So you should have one integral plus another in. This is your region, subregion A. For A, what are my endpoints? Good, 0 to 6.4174. And then when I do top minus bottom, it's this top minus this bottom. So what function is this? F of x or square root 2x. And then what's this? -2. So it'd be f of x minus -2. Okay, then go to your part B. What are my endpoints? Very good. 6.4074. Or until 12. And then for this piece of the graph, what's the top border? G of x, and the bottom border is still -2. So it'd be G of x minus -2 for your integrand. And then just go ahead and put that in your calculator. Now, someone in first period had said, should I call this Y3? If it was complicated, maybe, but if it's not, I probably wouldn't, but you can. Okay. Takes you probably less time to type in a -2 than a -Y3. So I got 43.7446. Okay, which would round to 43.7447. Okay, remember on the AP test, technically you only have to round to 3, but I would round to 4 so that if you mess up on the 4th, you don't lose a point. So if you get it wrong at the 3rd decimal, they're going to take off. But if you get the 4th digit wrong, they're not even going to look at it anyways. So if you're not good at rounding, just go to 4 every time and it'll kind of eat your mistake for you. Get the idea? Okay, so your test review is due today. That's priority number 1 because we're not taking a test. That review is the test. So you have about 40 minutes. Okay, if you have that totally finished, I'm going to come take it. Okay, you do have the answer key online. There were 2 mistakes that have been fixed. So if you already checked your work, then I'll tell you it was number 11 and I think number 24.